let's continue with 5.2. We're just going to look at a few examples that'll be similar to problems from your homework, and then we'll use the applications, properties, principles, equations from the reading as necessary. Of course, you've already done the reading for this section. So let's see. Number one, let's just kind of set that up. We want to evaluate the Riemann sum for f of x is equal to 2 minus x squared for x going between 0 and 2, with 4 subintervals, taking the sample to be right endpoints. So since n is equal to 4, that means that delta x is going to be b minus a over n. B here is 2, so we get 2 minus 0 over 4, or 1 half. So we can see that x sub 0 is going to be our starting point of a, which is 0. X sub 1 is going to be 0 plus a half, or just a half. X sub 2 is 0 plus 2 halves, which is 1. X sub 3 is 0 plus 3 halves, which is just 3 halves. And x sub 4 is 0 plus 4 halves, which is 2, which is that right endpoint. So I know it seems silly to be adding that 0, but you do kind of want to get in that practice because it's easier to see what your x sub i's are going to be here, and you can see that that makes sense with what we did. We had this was a 1 right here, so this was x sub 0 was 0. This is 1 half. This was what x sub 1 was equal to. X sub 2 was 1. X sub 3 was 1.5, or 3 halves, and this is x sub 4, where again that matches up with our n value of 4 right here. So using our definition of the Riemann sum, we say that we have the sum I going from 1 to n f of x. Now for right subintervals, we're going to be doing f of x sub I delta x. So for us, this is going to be the sum I goes from 1 to 4 f of x sub I times delta x. Now delta x, as we said, was 1 half right here. Now what is x sub, well, now we can go ahead and go through. We know what our x sub i's are, so this is going to be, when I is equal to 1, we have x sub 1, so we have f of x sub 1 times a half plus f of x sub 2 times a half, and so on. F of x sub 3 times a half, come down here, plus f of x sub 4 times a half. So since we're using those right endpoints, 1, 2, 3, 4, we're using these right endpoints for these subintervals. Now 2 minus x squared, by the way, it's actually going to look something like this, I think. So we're kind of using rectangles that look something like this. And this one's actually going to give us a negative area. Alright, so you should be able to pretty much take it from there. For example, f of x sub 1, that's f of, what was x sub 1 equal to? It was equal to a half. So you have f of a half times a half, plus f of x sub 2, which is 1, times a half, plus f of x sub 3, which is 3 halves, times a half, plus f of x sub 4, which is 2, times a half. So take 1 half and put it in there. So for example, for f of 1 half, you have 2 minus 1 half squared times a half, and so on. Evaluate it at 1, 1.5, and 2, and add all those up. Alright, so try that one out, and let me know if you have any questions. Let's look at another example. Number 7, you're doing something similar. You're going from 0 to 25, f of x dx. Only this one, you're not given the function value, you're not given the formula for the function, you're just given function values at a certain point. So we want a lower and upper estimate. So what you're going to want to do is, first of all, approximate it with a lower estimate using left endpoints. So you're going to probably want to take, notice that your delta x here is, you have 1, 2, 3, 4, 5 subintervals, 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25. And so your delta x is going to be 25 minus 0 over 5, which is just 5, and that's exactly what you see, the change in x as you go from one column to the next. So you're going to start off probably with, well, your lower estimate you could say is going to be the sum I goes from 1 to 5 f of x sub I minus 1 delta x. How's that going to work out? That's going to be, we'll say, the sum I goes from 1 to 5 f of x sub I minus 1 times delta x, which is 5. which is f of what? 1 minus, that's f of 0 times 5 plus f of, well, let's say it this way. Actually, I don't want to say f of 0 there. I want to say f of x sub 0, f of x1 times 5 plus f of x2 times 5 plus f of x3 times 5 plus f of x4 times 5. Okay, so using the left endpoints there, basically. Now, what is x sub 0, x sub 1, x sub 2? Well, x sub 0 is your starting point of 0. X sub 1 is your next x value of 5. So then you got f of 10 times 5 plus f of 15 times 5 plus f of 20 times 5. Alright, so that gives you, whatever it gives you, that gives you your left, or your lower estimate. Alright, so you want to do the same thing with the upper estimate, and for the upper estimate, you're going to use the right endpoint. So the right endpoint, you're going to use I going from 1 to 5 f of x sub I times your delta x, which is 5. So then you're going to take basically f of 5, f of 10, f of 15, f of 20, and f of 25. Alright, so I'll let you guys take it from there. Now, number 20, you can look at example 1 out of your book. It follows pretty straightforward from there. Number 20 out of your homework section is just like example 1 out of your book. So take a look at that one. 22, you have one similar to 22 in your homework. We did one like that in the previous lecture. Let's take a look at 31 maybe. And let's just look at 31, oh, I don't know, 31b. We're integrating 0 to 5 f of x dx. Now, looking at that in your book, all we're doing here, this is the area under the curve from 0 to 5. So if you look at the function that you're looking at here, well, it looks something like that, but you can see that here is 5. We want to integrate from 0 to 5. So basically what you're doing is you're finding this area under the curve right here, this area under the curve. And so you have to divide that up into a couple different pieces. For example, you'll find the area of this triangle from 0 to 2, plus the area of this rectangle from 2 to 3, plus the area of this triangle from 3 on out to 5. So you're going to have, what, 2 times 3 and a half of that. So 1/2 of 2 times 3, that's that triangle right there. The rectangle has a height of 3, a width of 1, 3 times 1, plus this triangle is 2 times 3 and a half of that. So what are we going to get then? We're going to get 3 plus 3 plus 3. Why did I take that back? This is actually a trapezoid right here. This is actually a trapezoid. So you can think of it actually, maybe do it like this. What's this area, this first part? It's not that. It's not that. It's, we got a little base rectangle here of 1 by 2. So it's going to be 2 plus the area of this triangle now, which is from 1 to 3 as a height. So it's going to be 1/2 times 2 times 2 looks like. So this is actually 2 plus 2. This is actually 4 for this spot right here. So you got 4 plus 3 looks like is your total area, which does give you that total area of 10. So that is this integral. Remember, the definite integral is just a number. It's the area under the curve. Now remember that you're also going to think of areas down below the x-axis. Remember, these are negative areas. So these are negative areas here. So it's possible you get a negative number for your definite integral if you're counting area below the x-axis. Okay, just a couple more examples then. Evaluating by drawing pictures. For example, number 36. We were asked to find the definite integral from -1 to 3 of 3 minus 2x dx. Well, you're just going to draw a picture here. So here's -1, 1, 2, and 3. 3 minus 2x, if you look at the function y equals f of x is 3 minus 2x. You just have a line here with a, looks like a slope of -2 and a y-intercept of 3. So we have a y-intercept here of 3, slope of -2, down 2 to the right 1. So like down 2, 1, 2 to the right 1, and so on. Down to the right 1. Let's see, and then up here we have to go up 2 to the left 1. So here's our line from -1 to 3. So we're basically blocking off here. We're going to have some positive area, looks like here, and looks like some negative area down here. So you just want to calculate the area of this triangle, the area of the yellow triangle, minus the area of the blue triangle. So this will be area 1 right here, minus area 2 right here. So basically, thinking of that as a negative area, so that's why you're subtracting it off. Okay, and finally using some integral properties for the last couple assignments. If you look at, say, number 41, you have the integral from negative 2 to 2 of some function f of x dx, plus some integral 2 to 5 of that same function f of x dx, minus the integral negative 2 to negative 1 f of x dx. Now, one property that we know is that we can actually switch the power, the sign of the integral, by switching the limits of integration. In other words, if I rewrite this, I can think of this as plus the integral from negative 1 to negative 2 f of x dx. Now, I point that out just to say that we can do that we can switch the order of integration by changing the sign of the integral. I don't want to do that in this case. What I want to do is use the property that says that the integral, well, basically what does it say? It says this: if we have a, b, and c here, we've got some function f of x. Well, if we take the integral from a to c plus the integral from c to b, that's equal to the total integral from a to b. So the integral from a to c of f dx plus the integral c to b of f of x dx is equal to the total integral from a to c of f of x dx. So if I look at these first two here, I've got negative 2 to 2, and then from there 2 to 5. So that's going to give me just a negative 2 to 5 f of x dx. So that's by combining the first two, right there. And then I got minus that negative 2 to negative 1 f of x dx. Well, so basically I'm taking off from negative 2 to negative 1 here. I've got, at this point, here's negative 2, here's 5, here's negative 1. We did have from everything from negative 2 to 5, but now I'm subtracting everything from negative 2 to negative 1. What that's going to leave me is just the integral from negative 1 to 5 f of x dx. All right? And you use similar concepts like that for number 42 as well. So I'll let you try that one on your own. Okay, good luck on this homework assignment. And as always, please let me know if you have any questions. Your password is asperse, A-S-P-E-R-S-E, and that means, there's a couple of meanings, one of which is to attack with evil reports. Sounds pretty vicious. A-S-P-E-R-S-E. Good luck. Let me know if you have any questions.